Chapter 4, Writing Reliable Tests, Junit 5, Mockito and TDD Workflow. Chapter 4, Writing Reliable Tests, Junit 5, Mockito and TDD Workflow is about treating tests as part of the design of a Java system, not as a safety net added after the important work is done. In serious backend systems, tests are one of the main ways we keep change safe. They let teams refactor, upgrade dependencies, change infrastructure, improve performance, and fix defects without constantly fearing that something critical has been broken. Junit 5 is the foundation of modern Java testing. It gives us the Jupyter programming model, a flexible extension mechanism, parameterized tests, dynamic tests, nested test classes, lifecycle hooks, and clean integration with build tools and IDEs. In practice, Junit is where we describe expected behavior. A good Junit test should make the system's intent clearer. When a test fails, it should explain what behavior was violated, not just point to some technical assertion that nobody understands. Mockito solves a different problem. It helps isolate the code under test by replacing collaborators with controlled test doubles. That is useful when a class depends on an external payment gateway, a repository, a message publisher, a clock, a notification sender, or another boundary that should not be executed in a small unit test. Mockito can stub return values, verify interactions, capture arguments, and make dependency behavior explicit. The key is to use mocking carefully. Mockito is powerful, but over-mocking can make tests brittle. If a test verifies every internal method call, it often locks the implementation in place instead of protecting the behavior. That kind of test becomes painful during refactoring because it fails even when the system still works correctly. A senior engineer should mock boundaries, not every object in sight. The goal is isolation where it helps, not artificial testing for its own sake. A good unit test is fast, focused, and deterministic. It should test one meaningful behavior. It should not depend on test execution order, real time, real networks, shared databases, or random external state. It should use clear setup, a clear action, and clear assertions. The common arrange act assert structure is still useful because it makes the test readable. Prepare the scenario, execute the behavior, then verify the outcome. Test naming matters more than many teams admit. A test called test order service tells us almost nothing. A test called should reject order when payment authorization fails documents a rule. When hundreds or thousands of tests exist in a codebase, names become navigation. They explain what the system promises. They also make failures easier to understand in CI pipelines. TDD, or test-driven development, adds a workflow around this. The basic rhythm is red, green, refactor. First, write a failing test that describes a missing behavior. Then write the simplest production code that makes the test pass. Then improve the design while keeping the tests green. The point is not to worship the ritual. The point is fast feedback. TDD forces the developer to think about the API, the behavior, and the edge cases before diving into implementation details. In enterprise Java, TDD is especially useful around business rules, validation logic, state transitions, calculations, mapping rules, and coordination logic. These are areas where small mistakes can be costly and where fast local feedback is valuable. TDD is less useful when the problem is mostly exploratory, heavily visual, infrastructure-driven, or dependent on unknown third-party behavior. Even there, the mindset still helps. Define what confidence looks like before trusting the implementation. Reliable test suites contain different types of tests. Unit tests check isolated behavior. Integration tests validate that real components work together, such as Spring configuration, database access, serialization, transactions, messaging, and security filters. Contract tests verify expectations between services. End-to-end tests validate critical user journeys or system flows. A healthy system does not rely on only one type. It uses each test type for the level of confidence it is best suited to provide. The testing pyramid is still a useful mental model, but it should not be followed blindly. Most systems should have many fast unit and component tests, fewer integration tests, and a small number of expensive end-to-end tests. But the exact shape depends on architecture. A system with heavy database behavior may need more integration coverage. A message-driven platform may need strong contract and consumer tests. A public API may need schema and compatibility tests. Senior engineers should design the test strategy around risk. One of the biggest mistakes is testing implementation instead of behavior. If the test knows too much about private methods, internal call order, or temporary design decisions, it becomes fragile. Better tests describe externally meaningful outcomes. A command is rejected, an event is published, a value is calculated correctly, a repository query returns the expected projection, or a transaction rolls back when a rule fails. These tests survive refactoring because they protect what matters. Another important practice is controlling test data. Good test data should be explicit enough to understand and small enough not to distract. Builders and local helper methods can make tests cleaner when repeated setup appears. The point is not to hide everything behind magic fixtures. The point is to make the important part of the scenario visible. A senior engineer should also care about test maintenance. Slow, flaky, unclear tests destroy trust. Once developers stop trusting the test suite, they stop using it as feedback. That is dangerous. Flaky tests should be fixed or removed. Slow tests should be isolated or optimized. Unclear tests should be renamed and simplified. A test suite is production infrastructure for the development process. The takeaway is that reliable tests are not just about coverage numbers. Coverage can tell us what code executed, but not whether the right behavior was protected. Good tests give confidence, document intent, support refactoring, and make design pressure visible. Junit 5 gives us the modern testing foundation. Mockito helps us isolate boundaries. TDD gives us a disciplined feedback loop. Used well, testing becomes a design tool. It helps us build Java systems that can change without fear.